Hello everyone, welcome to our 14th R&D session. I'm Monica Fernandes from EDP New, and I'm the new host of these R&D sessions. And I'm very excited because these sessions are very interesting webinars that we organize for different topics in the energy sector. And you might know that we have been having these sessions since last year. So every month we organize a webinar in a different topic. So we have been having sessions about different topics like hydrogen, renewable energy communities, and today we will have a session about local energy and flexibility markets. And for this, my colleague Gisela will lead this R&D session, and we will have a set of experts that will share their views and will help us to have a more clear idea about this concept. And I encourage you to ask all the questions that you have in the Q&A chat, because in the end we'll have some time for our guests to answer to all of your questions. And that's all. I wish you a great session. And now I pass the screen to my colleague Gisela.
Okay, hello everyone. Good afternoon. Welcome to this new R&D session. Today the topic is local energy and flexibility markets, as Monica has just said. And the agenda for today is, after a small introduction, where we will explain the rationale for the local energy and flexibility markets. We'll have a presentation to explain the concept behind these local markets we are developing in Dominos project. And after that, we will present the results of a cost-benefit analysis over several business models proposed by the project Dominos. In the end, we'll be more than happy to answer your questions, as Monica said. So I would like to invite you once again to leave your doubts, comments, suggestions in the Q&A. Okay, so as we all know, the increasing penetration of renewables and other distributed energy resources in the distribution grid, along with more active consumers and prosumers who could also have distributed energy resources behind the meter, are bringing forward new challenges for the energy system. Power production is shifting from centralized to more dispersed and distributed deployments, and from entirely dispatchable forms to significantly more intermittent and unpredictable ones. This means that instead of traditional load-following energy systems, the future will be more dynamic, and it may be more market-driven as well. Therefore, the flexibility from these distributed energy resources is of most importance in this new context, and those resources need to be available and visible on all levels of the energy system, so they can be considered while we are operating and managing the future energy system. On the other hand, the local comfort and requirements for the client side, together with the limits set by the distribution grid, must be considered as well. So a transition from a centralized approach to energy market towards a future distributed and dynamic approach is a potential part of the solution, enabling distributed energy management and addressing local congestions. Other benefits of local markets are linked, for instance, with an increasing energy dependence due to energy sharing within the local community, also to contribute for unleashing new business models and business opportunities for different stakeholders, and also from the DSO's point of view, exploring flexible resources could improve the quality of service and lower grid losses. So in this session, we want to address several questions, namely, what are in fact these local energy and flexibility markets? Which partners and parties are involved in these markets? What are the requirements and barriers for building a transparent and liquid local energy and flexibility markets? And also, what are the benefits for all the participants? So to investigate this concept of local energy and flexibility markets and discover the answers for the questions they have just mentioned, EDP, together other 7 European partners from 4 different countries, are working on the Dominos project. So basically, Dominos is aimed at designing and validating a transparent local market framework, developing and demonstrate ICT components that will enable the implementation of services for demand response, energy and flexibility aggregation, and local markets interface and operation. Also to formulate innovative local market-enabled business models, and also to analyze solutions for secure data handling related to the market-enabled transactions. This project, Dominos, kicked off in October 2017 and is about to end in June this year. We count with 3 validation sites, 2 in Portugal and 1 in Finland. The overall budget is 4 million euros, and this project is coordinated by Enerin, which is a Finnish company specialized in energy markets. Moving on the agenda of today's session, so we can learn in more detail the concept and framework we are envisioning for these local energy and flexibility markets in Dominos project. I would like to introduce my first guest. He is Ian Segastam. Ian is the strategic director of the Nordic energy information management company Enerin, the coordinator of Dominos, as I just mentioned before, which specializes in software-driven energy markets, enabling service solutions for energy-driven business through multiple European projects and collaboration across the energy value chain in Europe. Ian continues to look beyond the status quo in developing emerging technologies and future energy system enablers. Ian, thank you so much for accepting our invitation. And now the floor is yours. Thank you.
Thank you very much, Gisela, and thank you for the wonderful introduction. It's been a very interesting project to work on, and I will share my screen here so that we can see the presentation that I'm going to give on local energy and flexibility market concepts and what we've been working on in the Dominos project. So basically, climate change is driving us to a different kind of energy system. So we're looking at an energy system that's going to be more distributed than before, and we're going to see more renewables. This means that there are both network challenges and also market challenges in order to capture the real value of new assets and also the flexibility of existing and upcoming assets. So we need new tools and we need new structures to make this work. As Gisela already presented, the Dominos project is our tool for this, so I won't really spend very much time on introducing the project itself. I'll go more into what we've been looking at. So in the project Dominos, we've been looking at how can we ensure that the right value is projected to the asset owner, the customer, in the center of all of this. So you have the local value of the asset, you have the wholesale value of the asset, and you also have the choice of simply using the asset for your own use, which gives you a different kind of benefit, because sometimes it also means that you will have less of an impact on the network, or it will mean that you will have less of a service to acquire from external parties. So all of these 3 different aspects you need to work with, and at the same time, the energy system needs to accommodate you also when you have the situation of not having your own asset. We call it the February problem. It's cold, it's windy, and it doesn't blow, and it is dark. So it means that neither solar or wind power is going to support you, and you will need basically the effect that you need from the network from other kinds of generation sources, or indeed batteries or flexibility. So all of these things have to be taken into account when you think about maximizing the value for the end customer. So what we see in Dominos is that the value needs to be interoperable so that you can see what it would mean to share the value either locally with your peers or across the networks over the energy market itself. So that is the base concept for working on a market level. And then also there might be a benefit from using your asset to make sure that the network can maintain the market capability for the time of delivery, which otherwise would be risked if your asset wouldn't be flexible. So all of these aspects need to come into play, and then it's up to the markets actually to show you what the markets favor most, and you as the customer make the decision on which of those values you then support. So we see the Dominos concept as a succession of events. So we built together a very simple roadmap of going to better value capture, which goes from setting up a local market to then having the transparent and interoperable model to work with the overarching market levels, and then also to be able to use flexible network pricing to then provide value for the asset itself from a network basis. So all of these aspects need to be there, but they can be introduced in succession so that you don't need to implement everything at once. So the concept impacts basically allow you to facilitate more renewables, allow you to have a local market while not singling out the value on the local market from the overarching market, which can give you additional value, and not also singling you out from the network, which might need your resources. So it's basically about making the energy system work together with everyone, while also having the option of reaping the benefits of having your own assets or sharing assets with your neighbors, or maybe overall in a business complex. So if we start with the market model, we need to set some objectives. So we put together a marketplace that creates relevant and liquid flexibility for distribution management, allows the prosumers to decide where and how they utilize their position, so that the value can be distributed the way they want, because in the end, they're the ones with the assets in the distributed game anyway. It also allows for local sharing. So you have the option of either sharing or taking part in the different kinds of price offerings that you're going to get through the mechanism. This enhances the penetration of the renewables, and it also allows to use the current structures and doesn't basically overrumple everything that's been built so far. So when you implement this kind of concept, you don't need to say, okay, let's stop everything, let's change everything. You can complement and you can experiment. So it is a controlled way of bringing in new capability into a market area. So what do you need to take into account when you start designing this? So the first principle is to basically subscribe to the ethics of having an open market. In an open market, you don't really control it. Anybody can set up a market and anybody can trade. And that's the way, at least in Europe, we've been trained in the last years to think, and it's also how the Commission sees the energy system evolving in Europe. So we need to subscribe to a market model. But we need to ensure that there is a platform on which the market can operate. That's the network. So the network needs to work, and rather than over-investing in the network so that anything can work anywhere at any time, we need to make use of the assets that we have so that we don't have an adverse impact on the environment, or basically use funds that could be used better for the benefit of actually going towards the renewables or things like that. So the network part needs to be in balance, and we need to include that in our market design so that we don't end up with a partially optimized market design, which is, from a national or even European point of view, not a good use of monetary or environmental resources. So the networks enable the markets to flow. The local markets, when we then set those up, they should incentivize the participants to share energy with everyone. And therefore, rather than singling out offers, they should embrace offers from everyone so that the value of the assets can be actually built on market principle, rather than, let's say, having to agree that, okay, we will share this resource over one building, and this is the fixed model in which it works, and there is no way of deviating from it. Because it then basically singles out resources, rather than saying, here's all of those resources, let's expose them so we can share them amongst each other, or share them with the neighbor, or share them with the network, whichever is best. And that also means that distribution pricing should take into account this kind of action, because if we don't incentivize through distribution pricing or distribution participation in the flexibility part, then we're not creating the incentive to have an efficient network base for the renewable market economy. So how do you evaluate then? So you don't only have the obvious benefit sharing between the participants, but you have the DSOs and the TSOs who could provide value, and then you have the market participants who could have value from your resource, like stated earlier. And if you then go the way of how the traditional energy market has been designed, which is not bad, but it's just a system that is based on the notion that there is a cascading model which ends in single network flexibility markets, and there is no other market for the flexibility at that time point. That worked well when we had an energy system of large generation resources that were shared over a market between participants. But now that we have a sea of different renewable resources, this doesn't necessarily make total sense, because we don't always know whether it's actually beneficial for the TSO to use the resource. It might be beneficial for the DSO to use the resource. And it might be beneficial for the resource to be shared locally, which might end up in even a better situation. So there's much more to be looked at in the new energy system, because it is being used in bidirectional ways on all levels of the network, rather than only on the TSO level, which used to be the case before. So that means that also the regulation that governs how we work with flexibility and how we work with the balancing mechanism, that needs to take these things into account. But we don't have to change everything to work with the Dominos concept. We can start small. We can set up a local concept, we can put it in place in together with the overarching concepts, and then we can go from there. So one step at a time. From an information structure point of view, we need to have the information on the local market that allows us to build the information package that we need to send to the overarching market. If we don't have that information available, but share something totally different and totally out of spec for the overarching markets, then we are creating the island effect simply from a technical standpoint. Even if we were open on a commercial level to say, yeah, sure, yeah, you can come in and you can bid, and yes, we can come out and bid on the overarching market. If we can't combine and collect and aggregate that information, we might not have the capability of actually entering a bid or activating a bid, because we don't have the required information. So when you do set up a local market, you can have all kinds of information, which is fine, but you also need to have the information that would allow the information to be aggregated and put up to the overarching market. And that's something to take into account as well. And there's been a lot of work on this also in other places in Europe, including the TSOs and DSOs collaborating on the Active Systems Management Report, which defines how one could work with the information exchange on flexibility, for instance. So there's a lot to work on there, but the main principle that comes from the Dominos project is that you combine these information requirements to ensure the interoperability of the markets. So what about the existing markets? Well, I touched on that already, but it basically boils down to having a connection towards the markets and working also with the settlement model so that it is possible to settle all across the different markets. If we don't have compatibility between the settlement models, then also there's a question to work with so that we don't end up in market islands again. So that's a thing to consider, and you can do this in different ways. So there's no one single way of doing it, but we've been working with one here in the Dominos project, and we feel that there's a good opportunity of learning from that, and then we're going to work further on that model also in the future. So achieving the local participation, it's a stepwise path. So you could start with basically just selling excess renewables to a retailer. Then you could start energy sharing. Then you could work with peer-to-peer, and then you could work with local trading, so that there's a more active a trading community going on. And then you can go into flexibility. Then you can go into a retailer-driven internal market. So far, you haven't really done very much outside of your local realm, but that's fine. You can start small, and then you can go forward. And if you then latch onto a retailer-driven internal market, again, you're pretty free to do whatever you want, as long as you then conform with the retailer-driven parts. But if you've started already considering that you could sometime work with a retailer, and maybe sometime you could then enter into a wholesale exchange through a gateway or something, then you have these options, rather than being stuck in a situation where your specific peer-to-peer structure simply just failed. Well, that's what it is. There's nothing that you can do to connect it to anything else. So you'll be ending up with let's say a structure on top that's disconnected from the others, unless you think about these things and the progression when you design the local market concept that you're going to implement. And then you could go to the markets as an energy community, and you could also at the end even sell flexibility to the TSO, or even across TSOs, depending on how the markets are set up there on the overarching levels. So you don't have to do everything at once, like said before. So this was more of a let's say detailed approach into the roadmap. So what are the base building blocks for the local market? The compatibility with the market sequence, that's important so that you get the settlement right. The information content, so you can actually trade between the different parties. You have products which have granular location information so that you have the network benefit there. And you also have a distinction between energy and flexibility, so that you know what kind of resources available for the activation of flexibility. And you implement local balance responsibility, which then means that you are capable of cascading the responsibility upwards and calculating the resulting effects of imbalance. And you can then implement bottom-up flexibility management, which means you can then introduce distributed decision-making and the uptake of the flexibility. So one thing that was mentioned was the market sequence. So when you think about the wholesale markets, you have, for instance, a system of a day-ahead market and an intraday market. They're marked by DA and ID on the slide here, on the WM, the wholesale markets. A lot of acronyms. So the wholesale market for the day-ahead, then you go to the flexibility market for the day-ahead, then you go into the energy market of the intraday and the flexibility market of the intraday. And here, the different phases of working with the offers on the local markets can work in these ways. You don't have to have all of these. You can have some of them. But the point is that you need to be somewhere in the time sequence so that you don't end up in a situation where you don't really know where you're committed and you don't really know how the balance progression can be made. So if you work with your local concept like this, it doesn't really restrict you very much, but it gives you the opportunity to grow when you see the time fit. And yes, you need the local balance responsibility so that you know who to call when you have an imbalance. And you then go to settlement per metering point. And that you can do by integrating the balance responsibility model so that you have either the complementary model, where you complement the balance responsibility, or you have the full balance responsibility model, so that you basically take responsibility of the whole game. Either or, these work to ensure that it is possible to work with the possible imbalances, and you are then capable of having the interoperability between the different market levels. From the DSO's point of view, you have a lot of new options that you could work with. You could have the possibility of integrating flexibility producers and different kinds of flexibility owners, which would make you a procurer of flexibility. So you could procure flexibility just like any other market party. This is something that, for instance, the Clean Energy for All Europeans package basically will bring within itself for each member state to decide on how to implement this. You could be a data manager, so you could basically work with the data flows to know what's going to happen in your network, so that you could plan your other mitigation issues accordingly. You could also be a grid optimizer, making use of resources and also optimizing grids to flow along the market paths. Or you could also be a technical validator, or many of these. The technical validator meaning that each trade would go through you, or basically you would get the information of the trade so that you could then take a stand on, okay, these we can take, that's too much, we can't take this trade. Basically allowing by constraining trading, the trading of most participants, and thus making the market accessible for as many as possible at the same time. If you have the nodal information, the information of the location of the resources available, that means that you could then work with the flexibility for your benefit in the network, either through issuing constraints so that everybody knows which area is constrained, or by using procurement areas so that you say, okay, in this area I will need some flexibility. So there are many ways that the DSO can benefit from the Dominos concept. And that, in a very short nutshell, is what we've been working on for almost 4 years. And I'd be happy to take any questions and answer any questions in the questions and answers session. Thank you very much.
Thank you so much Ian, for your clear presentation. I think it was very interesting. So let's move on for the second part of our presentation. I hope I'm sharing my screen again. I would like also to remind the audience that you can leave your questions in the Q&A, so don't be shy. We will try to answer all of them by the end of the session, okay? So let's move for the second part of our session today, now that we are all more aware about the concept of local energy and flexibility market. So today with me I have here 3 guests to help me on this second part, which is related with the results of the cost-benefit analysis that we done for several business models designing the project. So basically, today we are going to present the results of this CBA for the flexibility provision to the DSO and use of transactive energy for network management. Also for a second business model related with the retailer as user of the local market. And the third one is related with sharing local energy in the scope of the energy communities. But before before introduce my 3 guests, I just would like to to say that the methodology adopted for performing the cost-benefit analysis over these different business models, it follows a common approach. And basically, the first step was related with the definition of the boundaries conditions and the set of the parameters. And after considering all the relevant assumptions, the identification, quantification, and evaluation of the key parameters were performed. Then the second step was the CBA itself. And then we performed also a sensitivity analysis. Here, we could have a recursive approach, allowing different iterations of the previous steps, so we can enhance the final solution. In the end, after the conclusions of the sensitivity analysis, the cost-benefit analysis results were assessed, and the range of values for the key parameters that enable the positive outcome were identified. So now, introducing my guest for this second part of the presentation. Today with me, I have Guido Pires. Guido has an economics and financing background. He's currently working for the Regulation and Strategy Department of ERETS, the EDP's ESO. As a regulation analyst, he has the responsibility of following any changes in the electricity sector regulatory codes, such as the quality of supply, tariffs, or commercial relation codes, and also responding to public consultation promoted by ERS, the Portuguese regulator. Hello, Guido. Thank you so much for accepting our invitation and to be here with us today. My second guest is Eduardo Rodrigues, my colleague. Eduardo holds a master's degree in electrical and computer engineer from University of Porto. Eduardo started his career working in R&D engineer within the power system automation business unit at the FASEC, where he was involved in multiple national and international innovation actions. Eduardo is currently working in R&D engineering and project management at EDP, working mainly on the topics of smart energy grids and distributed energy resources integration, and namely battery energy storage system. Eduardo, it's also a pleasure to be with you today in this session. Last but not least, we have Sala Nala. Sala works as a postdoctoral researcher at LUT University in Finland. Her research interest includes local energy markets and energy communities, utilization of distributed energy and flexible resources, and consumer and prosumer behavior in energy market. Sala, also, thank you so much for being here today with us. So let's move on for the first results of the cost-benefit analysis. Guido, it's your turn. Thank you, guys.
Thank you, Gisela. I'm now going to share my slides. Okay, so the two topics I'm going to approach in my section are flexibility provision to the distribution operator and the use of transactive energy for network management. First, there are two ideas that would need to be clear. The first of them has to do with what's the role of flexibility in the electricity sector. When we speak about flexibility, we speak about expecting consumers or prosumers to have a flexible behavior. And this can be done in many ways. There are different tools to make consumers or prosumers, we are speaking about all of them together, to respond to signals or to incentives that are created. One of them is through pricing. We could speak about static or dynamic, but
sorry, Guido, sorry
yes?
to interrupt. We are not seeing your slides.
No? Okay, then thank you for interrupting. I'm gonna try it again. Can you see the slide now?
Okay, now we can see. Thank you.
Perfect. Okay, this will help understand my reasoning. Okay, So when we speak about flexibility, there are different ways of promoting flexibility or expecting flexibility from consumers and prosumers. As I was saying, one of them is through either a time of use, static time of use, or dynamic pricing. Another one, and the others, which will be the focus of this discussion here, will have to do to expecting consumers or prosumers' responses after those responses being requested by the distribution operator. This analysis was made from the point of view of the distribution operator. The agents, either the consumers or the prosumers, would be flexible by either reducing consumption during peak hours, by shifting consumption from peak hours to off-peak hours, or even in the case when they have generation units, they could be injecting energy when requested. In terms of the use that the flexibility transactions can have from the DSO point of view, there are some potential benefits that the DSO can collect from the procurement of flexibility services. In the medium or long term, we could think of decreasing the needs to invest in the network to accommodate peak consumption or to lower technical losses. Whereas in the short term, we could think of flexibility procurement in terms of congestion or interruption management by the DSO. The flexibility markets in Portugal are, I would say that they are still at a very early stage. The main flexibility approaches that we have are focused and mostly managed by the Portuguese TSO, which is also the global system manager and operator in Portugal, REN. So we have interruptible contracts that large customers can join, and that possibility of the interruptible contracts exists since 2010. And also more recently, the Portuguese regulator promoted a pilot to test the participation of large consumers in a tertiary reserve market. This pilot project is mainly focused on the generation markets. However, the Portuguese DSO, Redes, in the first case, the interruptible contracts, the Portuguese DSO has the possibility of requesting the TSO to make use of the interruptible contracts, whereas in the second case, the Portuguese DSO has the possibility to see any transaction that happens in customers that are connected to its networks. These are the two main, if we exclude the case of tariff, these are the two main approaches and situations of flexibility that we currently have in the Portuguese regulatory framework. However, putting the DSO in the whole scenario and managing these transactions, we don't have yet that flexibility market existing in Portugal. So from the point of view of a whole local energy and the flexibility market, we could see the main flows that would exist in terms of information, data, and energy. And we would consider the DSO to be an agent responsible for buying flexibility services, either directly to producers, prosumers, or consumers, or through aggregators. The platform that would put all those transactions together would be the local marketplace. To have a quick view of how the sector is structured in Portugal, we have a little bit more than 6 million customers in Portugal. Most of them served by Redes. We are the main Portugal DSO. We distribute electricity to more than 99% of total customers in mainland Portugal, and we distribute around 45 terawatt hours of electricity. Our network extension is of around 220,000 kilometers. We have allowed revenues of around 1,000 million euros, and if we exclude concession rents, which are around 25% of the total allowed revenues, if we exclude that part, we will be speaking about distribution as having a weight of around 20.5% of the customer's final bill. We invest every year between 250 and 300 million euros in our networks, and we have a regulated asset base of around 3,000 million euros. We also have a regulatory rate of return on the investment and on our asset base that has a reference value of 5.75%. Another idea that is important to retain here is that we are in general a warm country in Europe. We are in Southern Europe, and our average customer bill, including taxes, is of around 45 euros per month for a residential customer, which lies quite below the average bill of a British or a French customer. This is important because, as we will see later, the potential benefits or the potential participation of residential customers in this type of markets will be obviously dependent on the benefits that those customers could have. And since Portugal has an average bill of electricity that is lower than the British or the French case, this also decreases the potential for the participation of smaller customers in supplying flexibility to the distribution operator. In terms of costs that were considered in our analysis, we could consider two main types of initial costs. There would be additional costs in terms of human resources, because there would be a new activity, a new task by the DSO, which would be the task of actively participating in flexibility procurement services, and this would be seen as an operating cost. On the other hand, we would need to adapt our IT systems and infrastructure to make the market possible and work properly and effectively in real time. This second type of costs, the IT systems and infrastructure, would be a cost of capital. So in regulatory terms, these two types of costs are treated differently. And this is one of the messages that is important to highlight here. In terms of what is established by the Electricity Directive of 2019, flexibility-related costs should be adequately recovered through network charges. And in the case of human resources costs, which are operating costs, the costs of procuring flexibility should be properly recognized by the Portuguese regulator. And for instance, in the Portuguese case, we have our operating costs subject to efficiency targets. In general, our operating costs need to decrease in real terms from one year to another. That is how our regulatory framework is set. However, regarding flexibility related costs, and according to what the Electricity Directive establishes, it would be important to have the costs related to flexibility, either operating or capital costs, fully accepted in terms of regulation and fully recognized in the distribution allowed revenues. So this is an important message to pass, which is the fact that a new activity, which is flexibility, should bring some benefits, but it also brings some costs. It would bring new initial costs and new ongoing costs. And these costs should always be considered by the regulator in the distribution allowed revenues. In terms of revenues or benefits that the DSO would expect, the main benefits would have to do to either congestion management or to decrease the network planning, the network investment costs that the DSO has. But it is important to understand that the DSO works in a fully regulated environment, and the activity of the DSO and its revenues must be recognized and accepted by the Portuguese regulator so that they can be recovered through network charges. Also, the DSO should only consider to procure or buy flexibility services when these services reveal to be more efficient than any other alternative. For instance, if the distribution operator has the possibility to invest in the grid, and that possibility is cheaper and more efficient than buying flexibility services, then the DSO should have the choice and should consider investing rather than buying flexibility. Therefore, it is very important to know here that the way the regulator will define the participation of the DSO in flexibility will have a very strong impact on the potential net benefits of flexibility from the DSO perspective. So in terms of main messages here, one of the things that need to be taken into account is that there are lower potential benefits for smaller customers, and this could be a barrier for these agents to offer flexibility. As such, aggregators will play a very important role in creating scale for smaller customers. We are speaking about customers that, on average, pay around 45 euros in their electricity bill every month, and therefore the gains from flexibility. There are some limitations to the gains, to the potential gains from flexibility. That is why aggregators will play a very important role in enabling smaller customers to participate in flexibility markets. On the other hand, larger consumers, which already have, all of them in general, the telemetering structure installed and which know very well what they pay for their electricity and are more able to respond to these flexibility requests, these larger customers will be more suitable participants than smaller customers because of their dimension and the impact they have in offering flexibility services. There are other variables that need to be taken into account, such as electricity generation prices, the level of consumption of the customers involved, and obviously, as mentioned before, the consumer average bills. There is another important aspect, which is the current context of the electricity sector in Portugal. In the last decade, consumption growth in Portugal has had very low rates of growth. And this means that the investment in increasing the grid's capacity is becoming a smaller slice of the total investment that the DSO makes. The DSO is now, the redes and the DSO is now investing, for instance, in increasing automation or increasing the rate of underground networks to increase quality of supply. There are many other aspects that require the DSO's investment other than responding to consumption growth. So the lower the weight of demand capacity responses in terms of investment, also the lower the potential benefits of flexibility. Also, because the DSO has a totally regulated activity, the way the regulator will set the rules for the DSO's participation will strongly impact both the success and the benefits of flexibility for the DSO. However, and because the DSO, especially in the Portuguese case, has more than 90%, more than 99% of all customers in Portugal connected to its networks, the DSO definitely has a very important role in terms of enabling all the new solutions that the grid has, and therefore the DSO will be seen in the future as a flexibility manager and also a facilitator of the use of new renewable energy sources that can deliver benefits in terms of the environment by promoting the use of renewable energy, but also for the customers, which can now participate with their flexibility, and the whole sector as a whole can benefit from the active participation of the distribution operator in procuring flexibility services. And from my part, it's all. Thank you.
Okay, Guido, thank you so much for your interesting presentation. So let's move on. Now we will, I'm not sure if I'm sharing my presentation. Give me just a minute. Okay, so let's move on for the second business model, retailer as a user of the local and of local markets. Eduardo, please go ahead.
Thank you, Gisela. Hello and welcome back to the R&D sessions. First of all, let me just apologize in advance for some background noise you may hear. So apparently there are some works going on around here. My name is Eduardo Rodrigues. I work at EDP New, and I will present you the highlights of the cost-benefit analysis we performed over one of Domino's business models, focused on the retailer and user and ultimate beneficiary of local market. The target business model provides the context for the participation of electricity retailers in local markets, bidding for energy and flexibility to supply their local portfolio and solve related imbalances. The retailer's main goal is to reduce costs by accessing lower prices and optimizing its upstream markets activity. Under the Dominos concept, for this business use case, the involved stakeholders are the retailer, the local market operator, and the energy / flexibility providers, or the engaged prosumers and flexible consumers. The analysis performed points to some aspects that may deeply impact local markets adoption, such as the evolution of national and communitarian regulatory frameworks, development of suitable. So I think we are losing the PPT. Okay, I think we are back. So as I was mentioning, the analysis performed points to some of these aspects that may deeply impact local markets adoption, such as the evolution of national and communitarian regulatory frameworks, development of suitable environments to foster local energy and flexibility markets, the continuous technological development of solutions fit to manage, aggregate, and activate distributed and flexible energy resources, and the evolution of electricity and energy services prices. So moving on to the next slide. Basically, in this picture, we have the framework proposed within Domino's project. Guido already presented as well. So particularly the articulation proposed and the interaction is expected between the different stakeholders help to frame the different business models. And in this case, we are looking into the involvement of the retailer at local level. The local market links energy flexibility, local procurement by energy providers to the energy flexibility offer from community prosumers and flexible consumers. The upstream interaction with the wholesale and balancing markets, which is part of the retailer's normal operation, is also illustrated. On the next slide, introducing now the financial analysis, the costs and revenues are breakdown. So on the initial investment, the proposed CBA targets well-established retailers, and thus their entrance costs are somehow neglectable. It's assumed that the investment required in a cold start situation is long time depreciated for well-established players, and generally these costs increase may be considered as marginal, like if they represent a restricted customer's portfolio expansion, for example. On the operating costs, these are mainly related to market access, for example, registration, accreditation, licensing fees, and workforce and infrastructure costs. These costs are dissolved in the retailer's OPEX, and an estimation of the value of the OPEX per customer can be considered to value them. Reference values used were collected from the financial performance reports published by Portuguese electricity retailers. Moving now, and regarding the operating revenues, in this new slide, well, the main parameters impacting will be presented next, and they were mainly extracted from the literature review since they are critical to calculate the expected revenues. They were also targeted by the sensitivity analysis performed. It's relevant to mention the influence of the retailer's local portfolio size, so the penetration of flexible consumers and prosumers, and the amount of energy generated and offered to the market, which are all relevant indicators pointing to the financial profitability and sustainability. Concerning the financial costs, the approach considers the adopted approach considers the reference value for the EBITDA per customer, also found in the financial performance reports published by Portuguese electricity retailers. Now, on next slide, and concerning the financial profitability and sustainability analysis of this business model, and also considering the previously mentioned assumptions and valuation methods, the following parameters were used to estimate direct revenues and costs. So the values considered are either linked to the validation environment proposed within the scope of Dominos, or come straight from the research performed. Revenues related, we have the required energy amount to buy in order to supply the 200 local customers and solve their imbalances, considering an average energy consumption per customer. The total amount of energy offered to the local market, considering the penetration of prosumers, the average energy generated per prosumer every year, and the percentage of generation made available to the local market as excess generation, and the average energy prices at the wholesale and local markets, where for the energy bought at the wholesale market, a 90% increase due to network access and global systems use must be considered. Cost related, we have the OPEX per customer, where 40% decrease was considered, since the costs are only related to market access, workforce and infrastructure, and other costs linked to customers management and billing should not be inputted to the retailer, but to the local market operator. Within this context, the outcome from the analysis performed points to an expected net present value of approximately 16,000 euros, summing the update cash flows for a 15 years time horizon. So these results show the outcome from retailers resorting to a local market to supply 200 customers using the excess energy and the flexibility provided by around 40 prosumers and flexible consumers also linked to that local market. So resulting in a nearly 2,000 euros of revenues per year, so across these 15 years. On next slide, I have the sensitivity analysis performed that provides an assessment over the solution's robustness to key parameters, considering the specific context studied and regarding the penetration of flexible consumers and prosumers in the local market. A reduction from 20% considered in the base case to 1% still leads to a positive NPV, since all the costs are linked to the number of active local players engaged. But for the percentage of energy generated and flexibility made available, with a reduction from 60% to 25%, a turning point is reached in terms of profitability. On the next slide, the sensitivity analysis is focused on other parameters also impacting revenues. For the wholesale market price considered, a negative NPV is reached if the price is only 2% higher than the actual energy cost. And for the reference price of the energy and flexibility at local market, only with an increase of at least 18% leads to negative outcomes in the retailer's perspective. On next slide, we focus the sensitivity analysis now on cost-related parameters, and for the OPEX and financial costs considered, they need to become 42% higher for the NPV to become negative, at least when compared to the values researched and published in the national retailers' financial performance reports. Finally, as a conclusion, tackling the risk assessment, in what concerns the qualitative assessment over possible risks associated to this business model, short summary will include the entering barriers, if the pre-qualification or other costs as fees are too heavy against the expected revenues, the retailer's perspective, it's not so great. Another risk can be related with the general market competitiveness that also influence the local market prices and consequently the profitability in the retailer's perspective, and the evolution of the legal regulatory context required to frame local markets, which is still being developed in most European countries. And that's it. I believe that's it from my side. Thank you very much for your attention. I will now pass the words to my colleague Sala, and we'll be waiting to hear from you at the Q&A session. Thank you.
Thank you so much, Eduard. So let's move on. Sala, please go ahead.
Yes, thank you. I'll try to share my screen. Okay, can you see the PowerPoint now?
Yes, we can.
Okay, good. Is it in the right mode?
Yes, it is.
Okay, I wasn't sure which screen it's showing, but I will be talking mainly about the energy sharing within a community and very shortly about ICT services facilitating local markets. So as the first business model considered, we are considering a model where a community manager assists an energy community in generation investment and also facilitates energy sharing and utilization of local resources via a dedicated ICT platform. And this, of course, brings the community members benefits through bill reductions and green consumption, but it may also help DSO congestion management. And in principle, this kind of business model could be adopted by a retailer, but the CPA was done assuming an external service provider as the community manager. And of course, this is a new type of service, so different kind of contracts are needed between the community manager and the members. And they might be a bit different depending on the member's assets. So if the member has flexible loads or generation, or if it's just a normal consumer. And this kind of service and request for them is driven by the increasing opportunities for distributed renewable resources and decrease in the price, the evolution in European legislation related to energy communities, and also that goes to the national legislation with a small delay. And then, of course, these community services might give opportunity for renewable energy investments for new types of end users also. And if we look at the financial analysis, we are considering now a community without pre-existing generation. So the community manager assists in the solar panel investment and related cost to that. And then other costs are the operating costs related to necessary ICT platform, which is now considered to be contracted via an external service provider. And then also there's need for forecasts, for example, generation forecasts, and that is also considered now an external service. And of course, some personnel is needed to operate the platform and assist the community in other ways. And we also consider grid costs related to the local generation, which is shared within the community. The consumption that's not covered by the community generation, we are considered that that comes from a retailer, and it's not considered here in this business model. And then, of course, related to the generation investment, there are some operation cost. And then if we look at the revenues, it was assumed that the community members pay a fixed service fee. And in addition, since the community manager is the one that acquires the generation, it then sells the generated energy to the members at a price that is lower than the normal retail price. And if all of the consumption is not used by the community, that is then sold to the grid. And it was assumed that this is financed by loans, and then also there's an investor who needs some profit for the service. And the base case analysis was done for a community with 2 medium commercial and industrial customers, 2 supermarkets, 20 small offices, and 200 residential customers. And for them, a 1,000 kilowatt solar PV investment was made, and with this kind of members, it was assumed that 87% of the generation can be consumed within the community. And this analysis was done for a 15-year project, and with all the assumptions regarding the different costs, the expected net present value was about 1.4 million euros. And of course, we did a risk assessment varying different cost components. These are just some of the examples. So we considered changes in personnel costs and change in the ICT platform license fee, because that was an external service also. But what we considered the big risk was on the left-hand side. So if there is any change in the community members after the initial investment has been made, then that is a risk for the profitability, even though still we got positive results with quite big changes. But if there are big changes, it might lead to a situation where a big part of the generation is not used within the community. So couple of marks on this business model. The legislation related to energy communities at the European level was established a couple of years ago, and while in Portugal, for example, the renewable energy communities are already in the legislation. For example, in Finland, this is not the case really, so we have much more restricted community legislation at the moment. Another thing is that this business model relies on availability and price of different kind of services, so the ICT platform and forecast services. So that needs to be taken into account. And then, as already discussed, the changes in the community members after the investment has been made is a risk. So it's really crucial to engage the customers before making the investment, and also there might be need for re-engagement if there is any changes in the ownership or occupancy of the participating buildings or companies. And then I'm going to very briefly mention one business model that we also considered. So many of these business models have considered that there is an ICT platform facilitating the local utilization of the resources. So here we considered this ICT service where a service provider manages a community and facilitates the local sharing and trading of energy and all also selling of flexibility services for other stakeholders. Or alternatively, this service provider could sell the ICT platform for other stakeholders' needs without actually being the community manager. So in this kind of business model, we would need to consider the development costs of the ICT platform. Of course, also here some personnel is required to operate the platform. And for the revenues, we considered that the community members would pay some subscription fee, and also the manager would get a share of the flexibility profits of the flexibility services sold for other stakeholders. And in this case, we considered public funding and own capital and loans as the sources of financing. And also here we ended up with positive net present value, but much lower than in the previous case. So to summarize, this case that we analyzed here showed a relatively low margin. So it's really important for this kind of service to focus on the scalability of the service for multiple markets. We didn't do the same kind of sensitivity analysis with actual numbers for this because there are many uncertainties related to this kind of business model. So of course, if there's a third party operating the market, there's even bigger regulatory risks perhaps than for retailers and DSOs. And then if we would sell this ICT platform for other stakeholders, it's quite difficult to assess the cost of making the necessary modification based on the different needs of retailer and DSO and different types of players and different types of markets. And finally, also related to the pricing model of this kind of service, if we would be selling this service for the community, there is the challenge of considering what are actually the revenues that we will get from the selling the flexibility, because the markets for flexibility are in many cases still quite much forming, so it's difficult to know in advance. But that was very quickly about this one, so thank you.
Thank you, Sala. Thank you so much for your presentation. So thank you, everyone. I think it was very interesting, and it's now time to move for the Q&A, because we have here several questions from the audience. Okay. So basically, I'm counting with you all, Ian, Eduard, Guido, and Sala, for this last mile of our session. My first question is for Ian. I think this is about your presentation. In the beginning, you mentioned liquid flexibility. Could you explain a little bit better what is the meaning of liquid flexibility?
Yes, so basically having liquid flexibility means that you would have enough flexibility available so that there would be an option for using a certain flexibility, so that you wouldn't have a single flexibility resource in an area. So that would create a situation where there would be the opportunity of finding out the real value of the resource rather than being constrained by the specific resource itself. This binds into the question of how we manage the locality of the flexibility in order not to be too constrained, so that we can ensure that liquid flexibility is available. So it's about making the area large enough so that there is enough participation to have the liquidity of the asset the trading.
Okay, thank you so much. And I think the next question is also for you. Our audience wants to know what we have implemented so far in Dominos project.
Yes, indeed. So we've put together the concept, and we've also tested different levels of the concept in the different demonstrators. So it means that we've looked at how the interactions work. We've looked at the information exchange, and also from the other presentations today, you could see that we've been looking at the business models as well. So as this is a research project, we've been looking at, you might say, the salient points of the model to understand how to make the model workable. And the next stage would then be to go to a larger scale of demonstrating an end-to-end use and end-to-end working of the solutions.
Okay, very good. Now we have here one more question, and I think it's also for you. Sorry, Ian. So this is a long one. If the prices of local and global markets would be different, how do you see the option of the asset managed to bid in the best one? Starting from the principle that the DSO, TSO cannot participate directly on the markets, the decision to bid should always be from the owner. So in my opinion, and the opinions of our audience, from the energy point of view, the market should be the same. Other topic is the constraint management and flexibility provision to the main ancillary services managed locally by these local markets.
Yes, it's indeed a long question,
yeah.
but I think a very good one, because it really demonstrates that you need to think through about the whole concept of the flexibility. And whereas right now we're in the situation where DSOs and TSOs don't necessarily bid, that might change. So that's not necessarily a given when we look at the situation where you would be basically looking at what the value of the flexibility would be for you, and therefore issuing a request for that. So then we talked about the local, we talked about the global, and we talked about the network value. So yes, there is a question in the network value that basically is reliant on the regulation on how the bidding can be done. But if you look at the local and the global, depending on which kind of market you have, but if you take for instance the intraday, you would have a situation where you would have knowledge of what the bid and ask levels on the global intraday would be, and you would also have then the knowledge of the bid and ask levels on the local intraday. That would allow you then to make a strategic decision on what price level you would put in on your own bid or ask on that level. So while from a theoretic standpoint, it's quite true that in an optimal world, everybody is on the same marketplace and everybody is bidding with the same mechanism, then actually, when you look at it from a more holistic point of view, because of the constraints that have been set by the energy system and the energy market, we're in a situation where the local asset might have different value on the local level than it would on those markets. So that basically creates a difference in the situation that will not basically say that local markets would not come about. So they will come about, and there are already the overarching markets. So the option of saying everybody should be on the same market, which from a theoretic standpoint is absolutely correct. You have most liquidity and you have most participants is everybody is on the same market. That's not really a realistic option when you look at the situation of the energy ecosystem. Then the last point in the long question was about the ancillary services, and those then come to the same realm when we think about what is the capability of the resource. So if you have a local market and you publish the location information, and there's also the capability of publishing your capability information, when a network buys that resource, it can use it for any one of its ancillary service requirements, not necessitating the kind of dedicated ancillary service markets that you see today with TSOs. So this is also an option that you can include into a local market design. And this is something that has been pioneered also in the interface and coordinate H2020 projects on a demonstration level with TSOs and DSOs. So there's a lot of things that need to be taken into account when you look at local and global markets and the network valuation. And I think it requires a brief assessment of all of those three layers when you actually set up your environment to understand how it will then work in that environment. But a very good question. Thank you.
Thank you for your excellent answer. So the next one, what are you doing in the two Portuguese demonstrators? Maybe Eduardo, can you explain us very briefly?
Yes, sure. So Dominos targets three different validation environments, but in two of them, in Portugal, we are actually using real data from a VPP environment and from a distribution grid environment from the village of Valverde in Évora. And on those validation environments, we are now, and after implementing the local market framework that was presented by Ian, we are now validating the use cases that somehow are linked to the business models we just presented and that were tackled by the cost benefit analysis. So generically, the real data coming from residential clients, buildings, commercial clients are being used to feed the local market module with the data from energy consumption, distributed generation, excess generation available to be provided to the market, and also flexibility linked to flexible distributed energy resources such as batteries that can foster this liquid flexibility to be offered to the market. And based on that real data, we will be validating these use cases and somehow try to assess how they cope with the preliminary results we reached through the cost benefit analysis presented.
Thank you so much, Eduardo. So next question. How large OPEX and CAPEX requirements could be funded in a local energy market? Maybe Guido, would you like to take this one?
Okay, yes, thank you. Well, regarding this topic, and I could answer particularly from the DSO point of view. Well, there could always be some sort of European support in terms of helping this type of new rules and transition alternatives to be implemented. But anything that has to do that is outside that type of funding, anything that the DSO wants to do to participate in these markets must be properly recognized by the regulator, so that the costs can be recovered by the network's tariffs. However, one of the main principles here is that the flexibility costs should always flexibility should always be an option whenever it is the most effective and efficient option for the DSO. And therefore, there could be OPEX and CAPEX large amounts, but after a while, after some years of being implemented, it would be expected that the benefits would be higher than the costs. Otherwise, there would be no reason for the DSO to opt for these alternatives. So in general, anything that the DSO wants to invest in, or any additional costs that the DSO wants to incur, if they are not funded by, for instance, European funding, then they have to be recognized by the network tariffs that are set by the regulator.
Okay, good, thank you. So next question. How granular do you expect the location information of flexibility products to be? I don't know, Gidi, if you would like to also to take this one.
Yes. In general, when these new solutions are implemented, and that has already been seen in the case of testing new, for instance, the participation of consumption in the tertiary reserve market, and also in a pilot that happened a couple of years ago to test new tariffs, new network tariffs. Usually, we start by testing the larger consumers, the larger participants. So in this case, probably the things would be staged, starting by the high and medium voltage customers. And in case the tests are successful, then we would try to analyze and test if the low voltage implementation will be successful or not. So in this aspect, and because we are also at a very early stage of these new solutions, I would say that anything that happens in terms of flexibility market implementation will start by higher voltage levels, and only after these ones prove to be successful, we will move on to low voltage solutions.
Okay, very good. So before closing the session, one last question. I think this one will be for Ian, our coordinator of the Dominos project. So Ian, do you really think that the local flexibility markets in low voltage and or in medium voltage grids can have liquid and competition?
The short answer is yes. The little longer answer is that actually, when we look at the levels of trading and the levels of volume, and also the levels of volatility, we find that the levels of volatility are very high also in small systems. And when you have very high levels of volatility, you have an opportunity for trading. And when you also have very local generation differences, as you do in a distributed renewable system, you also have differences that require balancing. So in that context, the drivers are there, and there are also mechanisms that allow you, for instance, to have automated trading between devices, which means that with a very low cost and a very low barrier of entry, and a very low intrinsic volume within the trades, you will have the opportunity of still having a market. It is different from what we see today in, for instance, intraday and day ahead on a higher level, but it is still a market. So you can have competition and you can have liquidity also in a small market, in a small scale, as long as you make the playing field such that it actually works. And that's an option you have when you make an interoperable market.
Okay, very good. So I think from our side, it's all. I just would like to say that Dominos is entering on this final stage. We are assessing the final results, taking advantage of the demonstrators. And in June, we will organize a final event where we will present the final results. So stay tuned to learn more to learn more about the outcomes of this project. Thank you all. Thank you for being here with us. Thank you so much, Ian, Guido, Eduardo, Sala. I know that in Finland it's a bit late already. So Ian and Sala, thank you so much for being here with us today. Thank you.
Thank you very much.
Okay, thank you.
Thank you so much.
Monica, don't know if you want to say something before closing the session. You are muted, Monica.
Thank you, Gisela. Yes, I just wanted to thank everyone, to our guests for the availability, and it was a really nice session. I'm sure that everyone here is much more knowledgeable about the local markets, and thanks to all of you. And also thanks a lot to our attendees, because we thank you for being here and for keep following us in every session we organize. And as usual, in the beginning of next month, we'll have another session in another topic in the energy sector, and make sure you don't miss it. So that's all. Thank you, everyone, and see you next month.